where the topic is mutual TLS for secure edge cloud data transmission in fast API web platform. If we get start with the abstract. So in the abstract, we could see that in the current world, we are facing a shift of data processing always from a centralized cloud data towards distributed mode of edge computing. While this allows for low latency interaction with device, it also massively expands the attack surface, making traditional permits secure solution inadequate. So we have come across with few of the solution for this problem, something like mutual handshake, mutual TLS, and JWT token with combined to give a certificate while a request is passed from edge to cloud or cloud to any other devices. That is a response. So these methods mainly track and identify the efficiency in a threshold standard called standard deviation, and this is ordered as mitigate effect of networks, and few of these are being identified before. So in this, we have a threshold limit. We need to achieve the target from 80 to 90, where that is the highest and most adequate latency threshold that we are going to achieve. In the introduction part, we could see that the industrial Internet of Things is progressing in a cloud computing architecture to decentralized architecture such as edge computing. These architectures can reduce latency and bottleneck in bandwidth using processing with the three layer of cloud, fog, and edge architecture. They are being used in the next front line of the cloud computing where sensitive data can be processed to enable real-time application. So these methods actually helps to reduce the physical devices and in different in same places, and it helps to uh, overcome many challenges in this current situation. So apart from this, security is one of the major threats. So we use a few of the methods like offloading and scheduling tasks for efficient task offloading. If the task is higher or if the task can't be done by the system itself, the task will be offloaded and the device itself will run the task in the edge device. In multiple agent weighted actant based approach, we also use uh, data integrity for digital twin. So data integrity will be increased while we use digital twin, where the copy of the information will be stored in the edge as well as the cloud device for safety and security purpose. So this is literature review. This supports the implementation strategy, and next we can go with the proposed solution. The suggested proposed solution is a zero trust framework which allows mutual TLS and JWT over a fast API and leverage much more secure communication framework. Here we are going to find two different statistics like standard deviation latency in sigma. So the HI denoted as sum of HI, the latency of individual request subtracted by the mu, the mean average latency of the request, whole divided by the total number of requests in uh, per request is like our target will be more than 1,000. So for the example, it is 1,000. So that's how we identify the standard deviation latency. After that, performance overhead, also known as the cryptographic tags. It means we need to identify the overhead across the secured layer from the baseline layer. So this is how it is identified. Where T secured is like known as the mutual handshake, and baseline is known as the normal approach as TLS. So this is the methodology that the system identifies and assigns certificate from a requested device, like from any kind of industrial sensor or any kind of local uh, computer system. So it takes the request from a gateway. It could be of any wired or wireless gateway, and it will be sending the request to the uh, security identity provider, where it will give the certificate as well as the JWT token for a high standard and higher reliable security system. This can be done from the cloud side also. So it will be stored in the cloud with a fast API server with a database. This is being used for the future purpose. In the block diagram, you could see that there are three layer architects, but in sensor layer and edge layer as well as cloud layer. So in sensor layer, it will give a normal certificate from the sensor reading from a small scale computer network. And from edge and cloud, there is an interconnected device that reliably check the authenticity of both the device, like edge as well as the cloud. So this will assign a special certificate for each device that could be validated from a single source security identity provider. So this is the flow chart. We will see this executional flow once we see the I mean the practical example. So these are the results and output. So in the results and output, we could see the baseline mutual transport layer comparison of latency and jitter analysis of 1,000 iteration. And this could be the efficiency part, like there is no other higher difference, only 8 millisecond difference in baseline as well as the standard TLS. So in the standard way, there is 1020, and the mutual way it is 1028. So we can actually alternatively use the mutual transport layer security or mutual handshake with a zero trust architecture. This will help us to increase the security with a slight change in the time duration for the authenticity and authentication. This also increase the systematic support, like you can see the cold state. That means cold start is something like hibernation. So officially both the technique use the cold start, but for better efficiency and better time management and systematic support, uh, the systems itself use a cold start. So whenever there is no request, it will be in an passive mode. But it always have a heartbeat that try to authenticate in a small scale way whether the system is in an active way or not. So in the conclusion, we have achieved our target of 82. Like we had a limited time change in the latency. So this tends to says that this method can be used and as an alternative way to improve the standard method, and it gives a mutual high level standard security. So we will go into the implementation part. This is the reference. So for the quick review, I'm just running the uh, code. Like I will do the launcher Python. Launcher is nothing but it will initiate the identity TLS and MTLS in a specific port number. So once these is being started, we can move into the Edge app. So here you can see the cloud. We can run it. So this will give you the cloud server control panel, that it get started, and local port and binding address, everything. So you can also select mutual TLS over TLS. So we are just going into edge system. Let's see how the threshold has been executed. So for the time constraint, I just limited the code and updated the time frame. Let's see that first. So this is like 10 iteration, and I have statistically changed the GUI model. So you can see the iteration has been started and the output is generated for the 10 request. So our target is 1000 requests. This is a general overview that this can be the analytical form that we used to identify the systematic throughput and data metrics. Although we can see the system final model in pi. Oh, sorry. Yep. So this is a systematic final view of the software that we can alternatively change the iterations, devices, models, that is TLS, TLS only, and MTLS. And the workflow identifies like JSON payload or file upload and cold start, cool down time. So this is about the workflow and the project. And now we can see the GitHub. In GitHub you can check the file format and file iteration and file mean functionality status. So what each files and what each folders consist of and how it runs. So I had uploaded a brief description about each file. Thank you.